Right, very good morning to all the students. Today's class, everyone,
Good morning.
right, good morning. Today's class, we are going to discuss the new type of chopper circuits. So in the choppers unit, we are having step down chopper, step up down chopper, which are the basic circuits. Now, yesterday we have taken 4-quadrant operation of chopper. We have stopped at the middle. We will continue the topic. But today's class, the topic which we are going to discuss will be tough topic, examination also, direct theory question. Now theory in the sense we are supposed to explain the circuit operationally. Okay. Now, so any chopper circuit, what is explanation when the chopper is on? So here in the circuit, in the place of chopper, we can directly mention the SCR or MOSFET or any object. Okay. So T1 is the SCR. So our main concentration in today's topic will be Jones chopper. So what is the speciality of this Jones chopper? Means we we explain in this circuit, we do contain capacitor, and this is called center tapped transformer. So why we are using this center tapped transformer? Because only single inductor cannot produce sufficient energy to turn off the main SCR. If single inductor is not able to provide sufficient energy to turn off the SCR, then we can go for the center tapped transformer. And single inductor operation is very much slow. Therefore, wherever if the energy is not sufficient to turn off the SCR by single inductor, there we can use this center tapped transformer. It provides more energy than single inductor. So, what is the speciality of this Jones chopper circuit? Means in this circuit we are representing the commutating elements. What are commutating elements? Capacitor, center tapped transformer, secondary SCR, auxiliary SCR or secondary SCR, and the diode. Okay. Now you can see basic circuit of Jones chopper. This is very important circuit for competitive examinations also. Okay. So you can see class D commutation we'll discuss. Already we have discussed class A, class B, class C commutation in the first unit. Class A is load commutation, class B is self commutation, class C anyone resonance commutation. Okay. 3 circuits, and in the examination they can also ask you explain class D commutation, the same circuit you are going to explain. Okay, circuit diagram we have to draw, and next what exactly the SCR T1. So SCR T1 is the main SCR to turn on the motor and to rotate the motor. Now once SCR is on, we are supposed to turn off the main SCR. How to turn off? With the help of commutating components. What are commutating components? Once again, capacitor, SCR2, and next one is the mutual inductor, that is center tapped transformer, to makes commutating circuit for SCR. L1 and L2 are closely coupled and they provide sufficient energy to turn off the main SCR. So in the circuits, if single inductor is not able to turn off the main SCR, then we can go for the center tapped transformer. So now, so first within 1 minute, I will explain the basic operation of the circuit. Now from today's class onwards, by seeing the circuit, you must be in a position to give explanation to any type of circuit. That is what the power electronics. Okay. Now you see. So case 1. So what happens in the case 1? So case 1 for this, especially Jones chopper, initially charged capacitor is selected. So the capacitor which is already charged separately with the help of the input supply to the full maximum voltage. If it is 5 volts, it will also be charged to the 5 volts. The case 1, initially charged capacitor is placed in the Jones chopper circuit. That means this capacitor is already charged to the input DC voltage. VC is equal to VDC. Okay. First case 1, capacitor is initially charged capacitor is used in the Jones chopper circuit. Under case 1 only, when the supply is on, direction of the current starts from VDC plus to Next, it will flow to SCR T1 because capacitor is already charged. So no current can flow through the capacitor. So when the supply is on, VDC direction of the current starts from VDC plus to SCR1. Now SCR1 is given the firing pulse. SCR1 is turned on. Therefore, direction of current flows from VDC plus to SCR1, and SCR1 to current comes down to this particular center tap point, SCR1 to this point, and then current flows through the L2. You can also say, sir, why not current can flow? If current flows through this L1 here right now, diode is on, and next current comes down here, this will be off here because current is entering cathode terminal. So capacitor is already charged, so no current can flow here. Okay, so therefore 100% of current starts in this direction when the case 1, initially charged capacitor is placed in the Jones circuit. When the supply is on, direction of the current starts from VDC plus to SCR1. SCR1 is turned on, and next SCR1 to L2, from L2 to the motor. Here you can write the, just like we represent in machines, M, you can write M. In this circuit they have shown the resistor and inductor. This is the motor, okay, DC series motor we can assume. So case 1 is all about initially charged capacitor is represented in DC Jones circuit. In any electronic circuit, before we turn on this circuit, we should see that capacitor and inductors are completely charged and energized. Then we turn on the circuit. Okay. So case 1 is initially charged capacitor is placed in DC Jones circuit. When the supply is on, direction of the current start from VDC plus to the SCR1, and SCR1 is on with the help of firing pulse. Firing pulse is not given to T2, it is given to SCR1. Therefore, SCR1 is on, current flows through this particular part and it enters the L2. During this process, inductor energizes. Okay, when it is energizing, this will be plus and here it will be minus. So direction of the current is from VDC plus to SCR1, that is T1, T1 to L2, and from L2 to directly to the load motor, and from motor to the VDC minus. This is what we are supposed to present in the examination first. So when the supply is on, direction of the current start from VDC plus to SCR1, SCR1 to L2, L2 to the motor, and from motor to the VDC minus. So during this process, motor accelerates. This word we have to put everywhere. During this process, motor accelerates and develops kinetic energy. And what should be the next point, anyone? And rotates in forward direction or clockwise direction or to the right hand side. So when the case 1, during this process, motor accelerates, develops kinetic energy and rotates in forward direction or clockwise direction. Now, okay, motor is rotating and its speed is controlled by the SCR. It is okay, it is done. Okay. Now, why you are discussing, why you are placing this center tap transformer, SCR T2, diode and capacitor? Only because to turn off the main SCR. Every student might be understanding now. The basic step up, step down and step up down chopper circuits are not showing the commutating elements, but Jones chopper is the modification of these circuits which contains the commutating components. When you go for a company and when you design a circuit, you can say, sir, I place the SCR, I can control the speed of the motor. But how to turn off the SCR, that circuit also should be shown by the engineer. That is very important. Okay. Right. So case 1 is clear. In every circuit case 1, we should turn on the SCR and then we should see how the SCR is controlling the speed of the motor. Once SCR is on, motor rotates, then that is the explanation we are going to give. Now we are coming to the case 2. Okay, I'll show the next slide here. 1 second. So here, what is the case 1? This red line indicating the direction of the current. You can see the case 1. From the supply, current flows to the T1, T1 is on, T1 to L2, L2 to the motor and this particular thing. Okay, first I will show this circuit only. I want every student to understand. By seeing the circuit, you must be in a position to give the explanation. Now we are entering the case 2. Case 2, what we have to explain? Case 2 and case 3, our target should be how to turn off the SCR. Case 1, SCR is on, it is controlling the speed of the motor, that's okay. Now the most toughest job is how to give the explanation to turn off the SCR T1. So now understand the concept. Case 2. Capacitor starts to discharge. In case 1 we have mentioned initially the capacitor is completely charged. In case 2, capacitor starts to discharge. So for capacitor, when it is discharging, it will never change its terminals. The terminals remain same. Okay. In case 2, the capacitor starts to discharge. The discharging current of capacitor flows from C plus to SCR T1. T1 is already on. When SCR is on, it is just like a copper wire. So from C plus to SCR, and from SCR to it comes down here. We are not giving firing pulse to T2. Now the current flows through the inductor because already certain amount of current has transferred to the inductor L2. L2 is completely energized. It is filled with energy. Therefore, now what's going to happen? Case 2, the capacitor starts to discharge. The discharging current of the capacitor is flows from C plus to SCR1, SCR1 to L1. Okay, this will be the positive terminal now for the L1. From L1 to diode, from diode to C minus. So from where the energy is transferring to that location only, energy has to return back. So you can ask, sir, why current now it will not flow through L2 and motor? Because already current was flowing through L2 and it is having completely filled with its own magnetic energy. Therefore, the new current will flow through the L1. So when the supply is on, current flows through the SCR, motor rotates, and after certain period of time, capacitor starts to discharge. The discharging current flows from C plus to SCR1, from SCR1 to L1, L1 to D1, D1 to the C minus. Examination, 2 different circuits you have to show. Power electronics subject, nobody will study the theory what you have written. New circuit, how the current flows. Dotted lines you have to show. Okay, right. So circuit, 2 circuits. Now it is clear. Case 2. Case 2. Capacitor starts to discharge. Discharging current flows from C plus to SCR, SCR1 to the L1, L1 to the diode, D1 is on, and from diode D1 to the C minus. Okay. Now here, one most important point you have to remember. So once again, now I will show this slide here. Okay. Right. So I will make it maximum for you people. You can see this circuit. But in examination, 2 different circuits you have to show. Here in the animation, it should be plus and it should be minus because current is entering this terminal first. So when the supply is on, current flows to the T1 and to the motor. Motor rotates, accelerates. That's in case 1. Case 2, what's going to happen? Capacitor starts to discharge. Discharging current starts from the C plus. Already T1 is on. It flows to T1, T1 to L1, L1 to the D1 and to the C minus. So during this process, capacitor is discharging now. Okay, and motor is rotating because already T1 is on. So you can see capacitor discharging part is from C plus to this particular. Now this point is very important. As to similar points you have to write in the examination. No need to refer any test. Once capacitor discharges, yes, many engineers they fail in this particular concept. What happens when capacitor discharges completely? When once capacitor discharges, it will again charge, but with reverse polarity, that is with upper plate negative and lower plate positive. So when capacitor is completely discharged, once again it will charge. How it will charge, I will explain. That is also the new point we have to write. Capacitor recharges with opposite polarity. That means the positive plate becomes negative, negative plate becomes positive. Why? I will also explain that one. Now you can see the down figure, second figure you can see when capacitor is recharging, its potential gets reversed, minus and plus. So now we are entering the case 3. Case 1 is all about VDC to T1, T1 to motor is rotating from motor to the VDC minus. Then what is case 2, all of you? Case 2 is discharging of capacitor. Capacitor discharges from C plus. That means the discharging current flows from C plus to T1, T1 to L1. Now L1 here it should be plus. Here it is wrong in the slide. It is plus, it is minus. From L1 to D1, D1 to C minus. Okay, case 3 we are entering. Case 3, recharging of capacitor. Heading we have to keep. Okay. Case 1, initially capacitor is charged. Case 2, discharging of capacitor. Case 3, recharging of capacitor. how the capacitor will recharge? It will recharge from the battery? No. If it is recharging from battery, the upper plate should be positive, just like the case 1. Now, this is the case 3 circuit. If you see here, in case 2, when the current enters the L1, this inductor is energizing. It is storing the energy. Now that energy is transferred back to the capacitor through the diode. If you see here, as already I mentioned, this should be minus and here it should be plus. Okay. So I'll go back to this one. So what is a case 3? Case 3 is this recharging of capacitor. How the capacitor will recharge. And no, don't look at this dotted lines. It is for different explanation. So let us go back to the previous slide in order to have better understanding. Now case 3 we are discussing. Okay. Now case 3, what will happen to the capacitor? Recharging of capacitor. How the capacitor will recharge? Capacitor recharges, capacitor gets the energy from L1 because initially current is entering through the L1, L1 is energized and that energy is transferred from the diode to the capacitor. Okay, from capacitor to the, again it has to come back. So what is case 3 means? Here it should be plus this one. Now inductor is de-energizing. So case 3 heading is capacitor recharges, inductor L1 de-energizes. Inductor L1 de-energizes. So when it is energizing, this is plus and this is minus. But now it is de-energizing. So it should be plus. This point should be plus and here it should be minus. So de-energizing current of inductor L1 flows from L1 plus to D1, D1 to, it is C plus now, C plus to C minus to T1 and from T1 to L1 minus. I want every student to be perfect with this case 3. What is case 3? Capacitor recharging and L1 inductor de-energizing. We can use the word L1 as inductor as it is center tap transformer. So L1 de-energizes. So what is the terminal potential? Here it is plus, here it is minus. So de-energizing current starts from L1 plus to D1, D1 to C plus. I already mentioned it will be reversed. So once again you have to draw the circuit, same circuit, and here it should, upper plate should be minus, down, lower plate should be plus. So from L1 plus to D1, D1 to C plus to C minus, and from C minus to T1, T1 to L1 minus again. Okay. So this is what the case 3. Okay, which is not highlighted in many textbooks, this particular point, how the capacitor starts to recharge. I can show here also. Here you can see once capacitor discharges, capacitor recharges, stored energy of load flows through the freely wheeling diode. This point is not highlighted, how the capacitor recharges. So capacitor recharges from the inductor L1 diode and capacitor. Now as the current is entering this terminal, it is plus and minus. And this part is not shown in the animation. That's why I've taken another slide. So I hope everybody are perfect with the case 3. Okay. I'm just repeating. Case 3 is capacitor recharging and inductor L1 de-energizing. So de-energizing current flows from L1 plus to diode D1, D1 to C plus, C minus, and T1 to L minus. Okay. Now capacitor is recharged once again. Okay. Case 3 is done. But what is our aim? Our aim is to turn off this SCR. Now one question I am asking, first unit I mentioned, at that time only, in the third unit I will ask this question. How to turn on the SCR? All the students, you can give the answer. How to turn on the SCR? In order to turn on the SCR, we should send the current to which terminal? Anode or cathode? Anyone answer me? In order to...
Anode.
Very good, very good. Now the second question. In order to turn off the SCR, we should send the current to which terminal? Cathode or anode?
Cathode.
Very good, very good. This logic everybody should be perfect. Then you can design any circuit. So I want to turn off this SCR. That's why I'm recharging this particular capacitor. So case 1 is what? From VDC plus to T1, T1 to motor, motor rotates. Your job is done. But second job is how to turn off this SCR T1. In order to turn off, case 2 says that, case 2 starts with discharging of capacitor. When capacitor is discharging, current is entering anode terminal. At that time, we cannot turn off immediately. So capacitor discharges, the discharging current enters L1, L1 gets energized, and from the L1 current flows through the diode, from diode to the capacitor C minus. Okay, capacitor is discharged completely, case 3. Now capacitor starts to recharge because of the energy of the inductor. Now you must be understanding why you are placing the inductors in the circuit and capacitors. They transfer the energy and they are useful to turn off the SCR. Now case 3, capacitor recharges with opposite polarity. This lower part becomes the plus, upper plate becomes the minus. So what is the direction of the current? L plus to D1, D1 to C plus to C minus to T1, and from T1 to L1 minus. Now we are entering the case 4. Okay. What is case 4? Case 4 is turning off the SCR, turning OFF, turning off the SCR and discharging of capacitor once again. Now the capacitor starts to discharge. Now what is the terminals here? This lower part is positive, upper part is negative. Okay. Now you tell me, anyone, how to turn off the T1? In order to turn off the T1, capacitor is discharging from this end. Okay, current starts from C plus. In order to turn off this one, we should send the current through this cathode. How to send? We are giving the firing pulse to T2. So case 4, capacitor discharging once again, and T1 case 4 is to turn off the SCR T1. Capacitor C is discharging once again, and firing pulse is given to T2, and T2 is on. So now the discharging current flows from C plus to T2. From T2 to it flows through the, it never flows through L1 because they are completely energized. They got certain resistance also. So current flows where the resistance is less. So we assume that resistance when the SCR is on, it is approximately equal to 0, internal resistance. Therefore, 100% of current enters the cathode terminal. So what is case 4? To turn off the SCR T1, capacitor discharges once again and SCR T2 is on. It is called auxiliary SCR. Its main job is to turn off the main SCR. So now current discharges from, discharging current is from C plus, the lower part is C plus now. C plus to T2, T2 is on. From T2 to current enters the cathode terminal, okay. Next current flows from cathode terminal to anode to the SCR and it comes back to the C minus. You can ask one question, sir. Current, if it enters the cathode terminal, SCR will be off. When it is off, how it will reach the C minus? The thing is, current flowing through the SCR, when it enters the cathode terminal, immediately it will not turn off the SCR. After a certain period of time, if the discharging current entering the cathode terminal is greater than the holding current of SCR, then the SCR T1 is off. Okay, this is the most important point we have to mention. So I repeat the case 4 once again. Case 4 is to turn off the SCR T1. Capacitor discharges once again, and this will be positive plate, upper one will be negative plate. T2 is on. So what is the discharging current? From C plus to, discharging current flows from C plus to T2, T2 to T1. Current enters the cathode terminal. Now from T1 to C minus. After certain period of time, when the discharging current is greater than the holding current of the SCR, then the SCR turns off. It is open. Now in this way, we are going to turn off the SCR. Okay, that is case 4. I hope all of you have understood case 4. Now case 5. What is case 5? SCR is off now. Okay, when SCR is off, motor will not stop suddenly. The motor contains the windings. So windings means inductor. Current flowing through the inductor cannot be changed suddenly. Therefore, when the SCR T1 is off, case 5 we are discussing. Energy released by the motor is freely wheeling or fly back through the diode D2. It flows in this particular loop and motor rotate continuously in the same direction. That is, in the absence of SCR T1 also, motor rotates for small period of time because of the energy stored by the inductor present inside the motor, and that current flows from motor to diode and from diode to the motor. It exists for short period of time. That means where we use this circuit means, again I am saying, let us say you are using that solar electric car. In NASA systems also they use the solar thing only, okay, solar panels. So when they are approaching one target, then what they do, they have to stop the machine How to stop the machine? You turn off the SCR-T1. When SCR-T1 is off, the machine speed starts to decrease, but machine rotates with lower speed in the same direction because of the energy stored by the inductor. So when you will get maximum marks, or when you will be placed in a company, means if they ask you to explain the operation of the circuit, you must explain with the application. So chopper circuits are used in the NASA satellites. So NASA is space launching, in all the battery operated vehicles. So if I want to turn off the machine, turn off the SCR, not to turn off the supply. When SCR is off, after a certain period of time, when energy released by the inductor is completely zero, then the machine also starts to turn off. Okay. So I repeat this explanation here. The next slide will be the same thing. The theory points, what we have written. Okay. The load current flows. This is the second. This circuit. No need to. This is the next one. Actually, no need to discuss this one. Okay. You draw this circuit. Leave that point. Okay. But follow our explanation. If you are taking this one, it is somewhat confusion oriented thing. Okay. This is the last one only. The energy flows through the motor in that manner. So just I just repeat this one. So case one, all students, I want every student should be perfect, because DC Jones is the toughest topic. Okay, right. What is case one? Who is ready? Come on. Case one. Case one is initially the capacitor C is completely charged, and the supply, when the supply is on, direction of current stored from VDC plus to SCR T1 is on, T1 to the inductor L2 to the motor rotates, accelerates, and develops kinetic energy, and rotates in which direction? All of you, forward direction, and then current flows from motor to the VDC minus. Right, VDC minus. Yes. Any doubt is there? Anyone? Right. Somebody is, I think, voice is coming on. Any question is there? You can ask. You are in a doubt unta adagandi. Yes, Monica. Any doubt is there? You ask. Okay. Right. Now, what is case two? Case two is discharging of capacitor. So discharging current flows from C plus to T1 to L1, and from L1 to diode D1 to C minus. What is case 3? Case 3 is recharging of capacitor to turn off the SCR T1 and de-energizing of inductor L1. So case 3 is what? L1 de-energizes, the current flows from L1 plus to D1 to C plus to C minus to T1, and from T1 to the L minus. Sorry, case 4 is all about to turn off the SCR T1. Case 3 we have done. Case 4 to turn off the SCR T1. So how to turn off? Now you can see capacitor discharges once again. Case 4, capacitor discharges, from discharging current flows from C plus to T2 is on, from T2 to T1, from T1 to C minus. So current flows through this loop that you have to show in the next circuit. So how many circuits? Each case one circuit you have to show. Okay. Now after a certain period of time, when the discharging current is greater than the holding current, SCR T1 turns off. When SCR T1 turns off, the motor rotates in same direction for small period of time, and then the motor stops when the energy released by the inductor is equal to 0. That current will flow in this particular loop. That is case 5. Case 5 is energy is transferred from motor to the diode D2, and from diode D2 to the motor. So in this way we are giving the explanation. No problems on this topic. Only problems on step up, step down, and step up down chopper we will take in the next class. Now I am giving one circuit to you. Try to give the explanation. So this is the circuit, all the students. So without thinking anything, now you will be in a position to give me the explanation. So what is this capacitor? SR, saturated reactor. Actually the symbol I will show you. What is the main advantage of saturated reactor? Means with very small amount of current entering this saturated reactor or inductor, okay, maximum magnetic field is created. If I am placing ordinary inductor, it takes a certain period of time. It requires certain current to create the maximum magnetic field. But saturated reactors are placed in power electronic circuits with very small current. maximum current will be created. Okay, that is the meaning here, saturated reactor. And the symbol is also different. We'll see. This is the exact circuit now, all of you. Let us discuss this circuit only. Our next topic is Morgan-Chopper and only theory. So I am confident that any one of the student can give the explanation, all the cases. And this is the textbook printout. In no textbook they provide the cases, what we are writing in the exam. So now come on, load means motor only. Already I mentioned, in order to provide the continuous current, we should place one extra inductor. That inductor is always placed in series with the load. Few textbooks will never show this one. So this inductor provides the continuous current. So that's why it should be placed. This is the motor. Okay. Now come on. So what is the use of capacitor? Anyone tell me? So Morgan-Chopper says that no need to use secondary SCR T2 if you are using the saturated reactor. This is the symbol of saturated reactor. Okay, this curved line. Right. So what are commutating elements now? Anyone student? The commutating elements are capacitor, saturated reactor, and diode D1, which are used to turn off the which SCR? SCR T1. This is not commutating component. It is freely wheeling type. Anyone can tell me the case one? Come on. So saturated reactor, yes, this one. Okay. Now I'll show this circuit. Okay. Now case one. Okay, let us make it fast. Case one, there are two techniques. What is the case one means? You can say initially the capacitor and saturated reactor both are charged and energized. Initially the capacitor is charged and a saturated reactor is energized. Both are completely filled with energy. You can write like that. Or when the supply is on, current first flows through the capacitor. SCR T1 is not given any firing pulse. It is off. Current first flows through the when supply is on, current flows through the capacitor to the inductor, that is saturated reactor to the motor, and from motor to the VDC minus. 2 points you can write. Okay. One type of explanation is initially the capacitor and saturated reactor is completely filled with energy. That's all you can do. Or VDC direct, when the supply is on, direction of the current flows from VDC plus to capacitor. We are not giving firing pulse to SCR T1. Okay. And current flows from C to saturated reactor to the motor, and from motor to the VDC minus. Okay, case 1 is done. Now case 2, or you can keep case 0 as charging of this one. Okay, right. Case 1 is done. What is case 2? Anyone tell me? What I have to do? I have to control the speed of the motor. Which component I have to turn on? All the students? Case 2. Case 2 is SCR T1 is on with the help of UJT firing pulse, and already this energizing components are completely filled with energy. So what is case 2? When the supply is on and T1 is turned on, direction of the current starts from VDC plus to T1, and because current cannot enter here because already they are filled with energy, VDC plus to T1, T1 to the motor, and from motor to the VDC minus. Initially also current was flowing, but it is not having any control. So what is case 2? T1 is on, VDC when supply is on, T1 is on with the firing pulse. Direction of the current is from VDC plus to T1, T1 to the motor. Now what is the point we have to write? Any student tell me? Motor accelerates, motor develops kinetic energy, motor rotates in which direction? Forward direction or clockwise direction, and then the current flows with VDC minus. Now what is the case 3? Anyone tell me? Case 3, what should be the heading? Case 3 is all about turning off the SCR T1. Okay. Right, case 3. How to turn off the SCR T1? Now, capacitor starts to discharge. Yes or no? Case 3, capacitor is discharging. Capacitor discharges from its positive terminal. So, what is the discharging current? C plus to SCR1. From SCR1 to saturated reactor. Now, this reactor starts to energize. This will be positive terminal. This will be negative. Okay. Case 3, capacitor discharges. Discharging current flows from C plus to SCR, and from SCR to saturated reactor. Saturated reactor stores the energy, and from saturated reactor to the C minus. Okay, now this is done. What is the case 4? Anyone tell me? Come on, this is challenging. Case 4 is to turn off SCR T1 and capacitor. Tell me, capacitor recharging or discharging? Anyone tell me? Case 4, capacitor.
Recharging.
Very good. Capacitor, now it will start to recharge. Recharge with which polarity? Same polarity or opposite polarity? All of you. Capacitor recharges with opposite
polarity.
Very good. Why? Because capacitor is recharging because of inductor here. Now inductor releases the stored energy. This will become positive here. I cannot mention, but here you understand this is the positive terminal and here it will be plus and minus. So you must draw the circuit once again in the examination. Case 4, capacitor recharges, T1 has to be turned off and saturated reactor starts to de-energize. The de-energized path is from SR plus, that is from SR plus to C plus, C plus to C minus to SCR T1, from SCR T1 to again SR minus. So in this way the capacitor starts to recharge. So what is the recharging path? From SR plus to C plus to C minus to T1, T1 to the SR minus. Now we are entering the case 5. What is case 5? All of you know. Case 5 is all about discharging of the capacitor once again. Now the capacitor, how it will discharge? Come on, how it will discharge? From C plus. This is initially the C plus, right? So what is the discharging path? C plus to SR, and from SR to T1. Current is entering which terminal? All of you tell me, cathode or anode? All the students. When capacitor is discharging once again, case 5, current enters from C plus to SR, from SR to which terminal? All the students?
Cathode.
Terminal of the SCR, and from cathode to C minus. Just similar circuit, same circuit only. Only difference, there we are using additional SCR, here we are using the saturated reactor. Okay. So now, so case 5 is capacitor discharges once again, that is from C plus to SR, from SR to cathode terminal of SCR1, from cathode terminal to the anode terminal, and from anode terminal to C minus. After a certain period of time, yes, tell me what should be the statement now? After a certain period of time, when the discharging current of capacitor is greater than which current? Holding current, the SCR turns off. When the SCR is off, the motor rotates for short period of time because of the inductor, as I mentioned. Okay, the same circuit. Let me take the attendance screenshot.